Hey everyone, it's Bradley Bush with another algebra video. Today we're talking about completing the square, one of the notorious topics in algebra. Our to-do list, we'll first review the quadratic equation, and then we'll talk about how you complete the square, along with two worked examples. I'll also put timestamps with each of the video parts in the video description, so if you want to skip ahead, you're welcome to. Let's start. What is a quadratic equation? Well, it's an equation that looks like this. You have constants, an a, a b, and a c. And then you have a quadratic term, meaning a term with a x squared or some variable squared. That's the most important term. You actually could drop off these last two terms, the linear and the constant term. You could drop off both of those and it still would be a quadratic equation, but oftentimes you see all three of the terms. So you have, again, the quadratic term, the linear term, and the constant term. And this is also called a second-degree polynomial or a parabola. Those are two different names for a quadratic equation. All right, big picture. Finding zeros, when we're finding zeros, when we're solving a quadratic equation, all we're doing is finding zeros. And when we're finding zeros, we're just trying to find the x-intercepts, these dudes, where the parabola crosses the x-axis. And sometimes the parabola doesn't touch the x-axis. So this, if you tried to solve this equation on the right-hand side, you wouldn't have an answer. You'd have an imaginary solution. There are many techniques for solving quadratic equations. You can factor, you can complete a square, you can use the quadratic formula, which, by the way, is just a shortcut to completing a square. You can use a graphing technology, or you can use the square root property. This video today talks about completing the square. I do, by the way, have videos for all of these techniques for solving quadratic equations in my algebra playlist, so you can check those out if you'd like. All right, how do you complete the square? Well, if you look at this quadratic equation here, it looks a little curious, right? The first thing you notice is the a in front isn't there. So we're assuming now that a equals 1. If it doesn't, in the situation you're given, you'll need to divide every term by whatever a is to make a 1. All right, the second thing is, you notice we have no constant term right there. It's just missing. So if you're given a problem with the constant term, you just simply take it to the other side of the equation. Or move it to the side, do what you're doing, and then bring it back afterwards. All right, so now you've got that out of the way. This is how you complete the square. It's actually pretty straightforward. You take the number, including the sign. In fact, I should probably, I'm going to make that sign red so you know that you include the sign. You take this number in front of, that wasn't what I wanted. You take the number in front of the x, or the linear term. You divide it by 2 and you square it. That gives you a new constant that you add to whatever you're given. If you have an equation, for example, x squared plus bx plus this new thing here, if you're adding b divided by 2 squared on one side of the equation, you also have to add it on the other side of the equation, just so your equation still remains valid. If you're adding a constant to one side, if you have 2 equals 2, and on one side of the equation you add 3, you've got to add 3 on the other side too to make it 5 equals 5. That's all I'm saying. Another way to deal with this is if you don't have an equation, if you're just given something without an equation, you can add that special term, the b divided by 2 squared, and then you can subtract it away. And that way, this gives you what you want, and then you have that extra constant left over that you deal with later. those are really the only two situations you'll have in this type of a situation. So this is what we do. We take the b again, we divide it by 2, square it, and we add it to what we're given, because that makes us able to factor this whole thing into something squared. That's the magic number that lets us factor perfectly into a perfect square trinomial. This b divided by 2 squared is what we need. That's the missing piece for us to create a perfect square trinomial. And a perfect square trinomial, or a PST, is just something that can be factored into a quantity squared. And I'll show you that right here. So we're given x squared plus 8x. If we wanted to create a perfect square trinomial, then we could complete the square here. So we're given x squared plus 8x. So what is the b term? Well, it's 8. So what we're going to do is we are going to add 8 divided by 2 squared. And then we also have to subtract it so we aren't changing our quantity, right? 8 divided by 2 quantity squared. And we will leave this part right here. Let's actually even change the color. We're going to leave that alone. So now actually what we've done is this first part here, I just highlighted in yellow, that can now be factored. Let's do a little bit of cleaning up and you'll see what I mean. What 8 divided by 2 is 4. 4 squared is 16. When we factor this, we can factor this into x plus 4 times x plus 4. And that is the same thing as x plus 4 squared. So that little piece there, the red piece here that we're adding, that 16, that was the magic number that let us take x squared plus 8x and turn it into something that could be factored into some quantity squared. So that's why we do it. That's the whole point of completing the square. The last step is this needs to come down and just hang out. So we would really have 8 plus 4 quantity squared minus 16. That's what we would have. Kind of fun, huh? I think that's actually pretty amazing. Now let's solve an equation. Let's use this idea and let's solve an equation. So we are given x squared minus 6x plus 4 equals 0. So again, I said if you have a constant there, you just need to take it to the other side. So that's what we're going to do. If we subtract 4 on both sides, then it's gone. So now we have x squared minus 6x equals -4. Now we're ready to try, or to use our method of completing the square. We notice that the a is 1. That's perfect. That's exactly what we want. So now we just take that b term, we divide it by 2, and we square it. And we're going to add that also on the other side of the equation. Let's see what we have now. Let's see, x squared minus 6x. -6 divided by 2 is -3 plus, squared is 9. Equals -4 plus 9, which gives us 5. Beautiful. Now this side here, the left side, is a perfect square trinomial. Because we added that 9. We created, like, we reverse engineered it. Meaning we made it be what we wanted it to be through a little bit of algebraic manipulation. Because this left side, you can see that we can factor that. And what does it factor into? X minus 3 times x minus 3, which is the same thing as x minus 3 squared equals 5. All right, we're getting really close. Let's move that 5 over a little bit. So the next step is to use the square root property. Let's make a note here. Use the square root property. I also have a video on that if you want to brush up on that. Really what it means is you take your function, I'm going to copy and paste here, and you take the square root of both sides. And you've got to have a plus or minus on one of those sides. So lucky for us, the square root and the square cancel. That's the whole point. And we have x minus 3 equals plus or minus root 5. Now we need to get the x by itself. So if we add 3 to both sides, we're getting really close here. X equals 3 plus or minus root 5. So this means we actually have 2 solutions. We have two solutions. We have x equals 3 plus 5, root 5, and we have x equals 3 minus root 5. And it looks like the x plus root 5 is this one here. That is not a very good arrow, right? There we go. That one. And our x minus, 3 minus root 5 is this x-intercept right here. So if you put 3 plus root 5 into your calculator, you would get about 5.236. And if you put 3 minus root 5 in your calculator, you'd get approximately 0.764. So there you go. We solved this equation using the method completing the square. Most of the time, people don't complete the square because they just use the quadratic formula, which is a shortcut for completing the square. But it's still a really good algebraic method to know. It's useful, and I've used it in my career as a mathematician. Hopefully this was helpful to you. Hopefully it kind of demystified a bit of the completing the square. If you liked it, please follow the channel, leave a comment. Thanks for watching.